right, good morning, everybody. Thanks for your patience while we sorted out some early morning audio issues there. Hopefully everyone can hear me in all the different rooms. My name is Jonathan Tower. I go by J for short. We're going to be talking today about Is Everyone AIing Without Me? .NET Developer's Guide to AI. So obviously, all you have to do is look at the schedule of sessions today to know that AI is pretty popular right now. You could argue that AI is the current buzzword. There's been a lot of examples of this over the years. Crypto and blockchain being maybe the most recent example of something that sort of blew up and was, every other talk at every conference you went to. Now AI is kind of that buzzword. But here you are, all in an AI talk, so maybe there's something to it. And in fact, did you know that AI is already solving real problems in the world? Has anyone ever heard of the AlphaFold project? AlphaFold project is something that is being done by Google's DeepMind AI. And this is solving a real problem that biologists have had for many years since we've started understanding the structure of life a little bit better. If you remember all the way back to high school biology, you might remember about amino acids creating proteins, and proteins being like all the machinery of life inside your body and any other life. And these proteins are super complicated combinations of all kinds of different amino acids and all kinds of different groupings. And they almost work like little machines inside of our bodies. And it's super difficult for scientists to see them and understand the structure that they take, because as they combine in certain orders, they also fold into different shapes. And those folding actions create the different shapes, and then the mechanisms that those proteins actually do is based off of those shapes in the body. And for a long time, the scientists have been trying to use supercomputers, all kinds of traditional algorithms to try and better predict how these different proteins are going to fold in different situations. And it's been very difficult for them to do that because it's a very complex problem that grows exponentially as you add additional amino acids to a protein. But thanks to AI, actually quite a few of these proteins are now understood very easily and relatively quickly, just by basically showing an AI the ones that we already understand and saying this is how these proteins have worked in this situation, training on that data, and then saying what about these proteins, what do they look like? And the AI has been actually very successful and very accurate at predicting this, which of course means that we're going to understand how life works better, we're going to be able to make medicines that work better for certain diseases, and a lot of biological things are going to be unlocked by that. So AI is already helping in that way. Another famous example a lot of people are aware of, you probably see a lot of clickbait articles about Tesla these days. I'll just tell you as a Tesla owner myself, I can tell you that some of those, maybe many of those, are not super reliable sources of information. Usually they're pretty hyped up, but a lot of people know at least that Tesla is doing AI to do full self-driving artificial intelligence. They're using machine learning. They're training it on millions and millions of videos from all of their different cars and using a machine learning algorithm that they're training on their own supercomputer. And then that machine learning model is being downloaded to all the different cars, and then that's used to actually drive the car. I can tell you, very recently a new version of this software came onto my car that replaced 300,000 lines of procedural C++ code. Which is already a little bit of a shocking number, but it replaced those 300,000 lines of code with all machine learning, and it's very noticeable. There was a lot of things that were a bit awkward that it doesn't do anymore, that it does much more naturally and much more human-like now as a result of AI. So here's another thing that AI is doing to change and improve our world. If you've been using a credit card, maybe you have a Visa card in your pocket today, and if you do, then you're also sort of unintentionally using AI anytime you tap or insert that into a terminal. About 76,000, at last time they published the number, Visa said about 76,000 transactions per second that they're running through their AI to look for fraud. So you've probably seen this. Your bank has probably sent you a text message, or maybe you've gotten a call or a message on their app or whatever that has said, hey, suspicious transaction, that's why you just got denied. And maybe you've even gotten those in the middle of the night when it was actually a suspicious transaction. Like somebody just tried to do something at Best Buy. That's a really popular one, right? In a city that you're not in, far away from you. And so Visa has actually been able to do this real-time monitoring. Their AI that they built is so fast, they can test a transaction in less than 50 milliseconds. Last time they published that data. And they've claimed that in certain situations, this is giving them a 300% improvement in fraud detection compared to the traditional algorithms that they were using before. So a lot of things in life that I think are proving that AI is here to stay, and AI is maybe not just a buzzword, but is actually something that is going to change our lives and our jobs as software professionals. So in this talk, I want to focus specifically on my .NET developer friends. I want to talk a little bit, first of all, about what are some of these AIs. You've probably heard some of the different terminology. Maybe you don't have a good mental map of how all these things fit together. There's tons of different types of AIs and machine learning algorithms. So we're going to talk just kind of a quick overview of those. Then I want to talk a little bit about when would you use AI, when would you use traditional algorithms. And then finally, I want to show you kind of a quick overview of a whole bunch of different tools and libraries and services that you can use as a .NET developer. Show you some code examples of how easy it would be for you to use these tools to be able to do AI as part of your .NET applications. All right, so before we get into it, just real quick introduction of myself. I mentioned my name is Jonathan Tower. I go by Jay for short, so if we get a chance to chat afterwards, feel free to call me that. You can reach out to me at any of these places online, and the slides and code that we're going to look at together today are available at this link at the bottom here on GitHub. And then also on the right-hand side of the slide, I just want to mention that I have a special offer for anybody that comes to one of my talks at conferences. Hopefully I'll have some time afterwards for some Q&A. We'll get Q&A through Discord here for the other rooms. But maybe you're a little embarrassed to ask some of your questions in front of everybody. And if that's the case, I'm happy to chat afterwards. I'm also happy to chat if you want to schedule a free consultation with me. That would be totally all right. You can use that bit.ly link or that QR code to do that. So I'll show all this information again at the end if you're interested in taking a picture of it. Okay, so let's start out by talking a little bit about the AI landscape as it exists. Back in 1999, when I graduated from college, I actually got an emphasis. My computer science degree had an emphasis in AI, which I now look back at and think is kind of funny, because AI in 1999 was pretty much in its infancy. Compared to what we're able to do with it today. And a lot of that has to do with some new technologies that have been invented, but a lot of it has to do just with the processing power that we have today that we did not have in our Pentium chips in 1999. But AI is a very complicated thing. This is a kind of hierarchy of different types of AIs. You've probably heard of some of these. And maybe you don't have a good mental map of how these things all relate to each other. It's not super important what this hierarchy is, but it's important to maybe know that all of these things are basically different types of AIs or different types of machine learning. And so I want to just kind of talk a little bit about what those are, just so that we're using the same terminology as we're talking about this stuff. So the first thing that we'll talk about is machine learning, which is a specific type of artificial intelligence. It uses statistical algorithms, and it can learn from data and then generalize that into unknown or unseen data. So a lot of the AI that you're familiar with today is a form of machine learning. And machine learning is kind of is related to neural networks. And neural networks are just a type of machine learning that is inspired by the way biology works. It's my second reference to biology today. After the AlphaFold one. But the way that brains in animals work is, you've got all these neurons, and they connect to each other with synapses. And as different synapses fire over and over again that creates a stronger connection between those neurons. And this is kind of how you build up the knowledge and skills that you have inside of your brain. And basically copying that model, we have these network of nodes that communicate with each other, essentially doing simple math between each other, between each other's input and output nodes, and you get a neural network. If you have enough nodes and you organize them in the right way, you can do things that seem somewhat magical, putting in data, like, for example, video from a vehicle that's driving, and you can get outputs on the other side that come out of like a black box that say things like turn the steering wheel a little bit to the left or hit the brake or whatever. So kind of an amazing technology there that mimics life. Deep learning. This is just really a subset of machine learning that's based on these neural networks and something called representational learning. And really what makes deep learning deep is just the large number of layers that are being used in the neural network. So we'll talk about this more when we're talking about some of the tools as we get into it. Of course, everyone's familiar with generative AIs. ChatGPT is probably the most well-known name out there right now in AI. Generative AIs are just deep learning models that are built in such a way that they're capable of generating things like text or image or videos. They do that by learning from a set of data that they're trained on and looking for the patterns and structures in that input, and then basically generating things with similar characteristics for the output. Large language models, specific type of generative AI. These are ones that are good at generating text, and these are, of course, what ChatGPT and other similar types of chat agents like that are like. Speaking of ChatGPT, what is GPT? Well, it's a generative pre-trained transformer. It's just a specific type of large language model, which is a specific type of deep learning, which is a specific type of machine learning that's able to do these rich human-like text interactions. You've probably also heard this term recently, RAG, which is retrieval augmented generation. This is a type of AI that combines the retrieval of relevant information, usually from some sort of corpus of documents, along with text generation to answer questions in some sort of a context. So for example, your organization that you work for might have a body of documents that are like employee reference manuals or reference information about things like your benefits and how do you request time off. If you train a large language model using RAG on that body of documents, then you can ask that large language model questions like, how do I request time off? And it's going to be able to give you answers in that context. And then the last one I just want to mention that you hear thrown around a lot is data science. Data science is just the interdisciplinary approach to using all of these different things like statistics, the scientific method in general, algorithms, and all this machine learning to extrapolate knowledge from a base of data. So when you hear someone talk about data science, this is what they're talking about. It's this interdisciplinary approach to use all of these things that we just talked about to help make decisions and make predictions. Okay, so with those terms out of the way, let's talk a little bit about when you might use traditional algorithms and when you might use AI. So AI is good at a list of things here that traditional algorithms find very challenging. So if you're trying to recognize an image and see what's in that image, you could try to write traditional algorithms to do that, but you can imagine what the if-else-if statement would look like. To parse all those pixels and try and make sense of it. And machine learning, deep learning specifically, is really good at doing things like that. If you're looking to classify text, like is this document this type or this type of document? Is this text a question or is it more of an answer? All of those types of classification are things that AI would be really good at. Speech recognition, so when someone's talking, to understand what they're saying, and to be able to also generate that speech from text. Recommendation systems, anomaly detection is another really common one. We were talking about Visa at the beginning. This is what Visa does to make sure that your credit card isn't being used fraudulently. And they basically look at your data and they look for outliers. And as soon as an outlier in the data happens, they flag it. And if it's a certain, it's above a certain threshold of certainty, they'll go ahead and block that transaction. And they're always adjusting those numbers basically based on how much money they're willing to lose at any given time. So predictive analysis, this is what we talked about a second ago too. AIs help you really look at past data and then make decisions based off of that for future. Pattern recognition is another thing that AI is really good at. Of course, content generation, if you're familiar with ChatGPT or some of the other OpenAI popular generative AIs, you can generate images and quite a bit of other stuff nowadays with these different generative AIs. And then chatbots. Probably a lot of us have logged onto a website and we've gone to the chat with a customer service person link and ended up chatting with what was clearly some sort of a robot to answer a good 80% of the most common questions and inquiries that come in so that the humans, customer service agents, can handle just those exceptional situations or more complex situations that are a little less common. So that's what AI is good at. What is traditional algorithms good at? Any kind of rule-based system. If you can describe it in words that use like the word if and else and then, there's a good chance that a traditional algorithm is going to be a lot better at it. Anything deterministic. When the temperature reaches a certain point, I need the thermostat to turn off the heater, right? That's a pretty deterministic set of rules. You don't need an AI to control that. Any kind of forms over data, I'm guessing most of us, like me, probably do largely applications that present data to users from a database in some way and allow them to interact with that. These applications, largely, there's really nothing that AI can add for you directly. Although we'll talk about some examples later on of things that you could do to sort of extend this type of application. And obviously AIs are a bit of a black box sometimes. It's hard to look inside and see what the algorithm was and why did it make this decision. So debugging it can be very difficult, which means that if you're looking for predictability and transparency, how did this work and why, and how can we make it not work that way in this type of situation in the future? You're looking really at traditional algorithms, not AIs. And that also applies to precision. So if you're doing something scientific, you're going to probably want to use some sort of an equation. You're going to want to use as exact measurements as you can to go into the inputs of that equation to get an exact or precise output. And AI is probably not what you want to do to try and figure out what trajectory your rocket should follow based on past data. Okay, so this is my thought, but I don't think that there's going to be a lot of applications that are just purely traditional, except for the smallest and simplest ones in the future. So maybe, even though I kind of joked that this is a buzzword at the beginning, I think maybe you're in a good session today if you're interested in learning more about AI, because I think as things go forward, just like software has gotten more complicated since 1999 when I started developing software professionally, I think this is a way in which software is going to get more complicated and we'll probably never go backwards and not have AI be part of our traditional applications. So I think you're really going to have two categories of larger applications going forward, and one is going to be ones that are a mix of traditional and AI, and then you're going to have some that are just simple AIs. So I think it'll be very important to build this skill over time. Okay, that's kind of all of the why and what stuff. So let's talk specifically about how you might use some of the tools that exist out there as a .NET developer to get started with AI. The first one that I want to talk about is Azure AI. This is a cloud-based service in Azure. So if you're already using Azure as a .NET developer, this is going to be stuff that's very familiar to you compared to a lot of other Azure resources that you're probably already using. But you can think of this as basically a way to outsource your AI into the cloud. So if you think, you know what, I'm probably never going to be some sort of a low-level AI expert, like I know some of the other speakers who are speaking about AI today are actually that level of expert. If you're like me, You probably think, oh, I'm never going to be a data scientist or anything at that level. This is actually going to be perfect for you because you can get all the benefits of AI. You can get a lot of control over how it works. You can very easily integrate it into your application, but you kind of don't have to worry about all those low-level details about how AI works and how to set it up. So Azure AI has actually been renamed somewhat recently from cognitive services. So if you've heard this name before out in the world, there's basically the same thing. Azure AI is just the new name for it. It's actually important to know that some of these services right now, if you start Googling the things that are out there on Azure for AI, some of these services you'll find have gone away recently. And the good news is that they haven't gone away totally. It's just that with the rebrand from cognitive services to Azure AI, Microsoft also said, you know what, we've got 5 different things that kind of are all similar to each other. Let's combine them into one service and call it some new name. So a lot of this stuff is just rebranding. And none of this functionality has actually permanently gone away. It's just gotten moved into other places. Now, there's a lot of services in here, and this isn't even all of them. This is just a lot of them. There's a lot of services available, as you can see. And in our time together this morning, I don't think we have time to even go through all of these. And I want to leave a little time to talk about some other more complicated ways that you can use AI. So today, I just want to focus on these 6. I'll give you some examples of using these 6 services, which I think are ones that you might commonly want to use. So we'll start out talking about using the Azure OpenAI service to use all the generative models that OpenAI has available. We'll talk about how you might build a bot service using .NET in Azure AI, the face recognition API, the language recognition API, the speech recognition and generation API, and then the translator API. So if you want to get started with the OpenAI service for Azure, it's very easy. You just get this azure.ai.openai NuGet package and install that into your .NET application. And you now have unlocked a bunch of functionality to connect to OpenAI. Obviously, you'll also want to set up an account either on OpenAI or an Azure OpenAI resource. Either one of those will actually work. The OpenAI NuGet package for .NET actually works with both direct connections to OpenAI, which has its own APIs, or if you want to connect to OpenAI through an Azure resource, you can also do that. And we'll talk just in a second here about the difference between using those two and why you might use one versus the other. But let's look at how simple it is to get started with this. Once you've got that NuGet package in and you've set up your resource in the cloud, let's go ahead and assume that you're doing that as an Azure OpenAI resource. Azure, like with most other services that are available over a REST API, is going to give you an API key and then a particular endpoint that you're going to hit for that resource. You're going to connect using the OpenAI client class, and then you can start sending it commands like this one you see here, which is to get a chat completion for a particular prompt. And that prompt in this case is to tell me a joke. And then you can get back that completion and we're printing out the message there to the console so that the user can see what the joke is. So very simple. It's almost just like how you would use ChatGPT if you were typing messages into the user interface on the web or in the mobile app, but you're doing it programmatically in your code. So you can imagine here that you could build up prompts based off of different data in your application or different data that the user provides you. You could create a more complex prompt and send that and get something back that you then present to the user. I promised that I would explain the difference between OpenAI and Azure OpenAI, and this is a chart that sort of tries to capture that. Both of them have 2 things in common. One of them is that they don't use your data for training. This is important for a lot of organizations. If you're starting to send your data up into the cloud, you want to know that that data isn't going to be part of some sort of body of data that they're going to then train OpenAI on going forward, and somehow all of your data is going to start being leaked when other people start asking ChatGPT questions, so you don't have to worry about that. In fact, if security like that is a concern of yours, you can, on either of these, you can opt out of having any of the history retained, any of the data retained, by just setting a setting. The things that make them different is the things you might sort of expect about Azure. Azure is more complex. It allows you to do things like having a point-to-point connection with your on-premise applications. You can do that, and so that only certain on-premise applications can connect through and talk to your OpenAI endpoint. You can create virtual networks within Azure so that only certain resources in Azure are able to access your OpenAI endpoint, and you can also set up access control, with your Active Directory or Entra ID now, that say only these, groups or people get access to this OpenAI endpoint. Those are all things that you can do if you use the Azure one. You cannot do them with the OpenAI one. Oh, I forgot about one, actually, which is regions. This one's pretty important. So if you have an application, a backend API web application that's running in a particular region, you know that if you put your database in a different region, that's going to slow down your application, because now your web application and your database are talking to each other over a slower connection between the different Azure data centers. And the same thing applies to OpenAI. If you want it to be as fast as possible for that backend application to communicate with, you want to make sure it's running in the same region, and you can do that if you're using the Azure OpenAI. All right, let's move on to the next one, which is bot service. I've actually got a whole talk where I talk about this for the entire hour. So if you're interested in learning more about this one, I know a lot about this one. This is, there's a lot of bots nowadays. You've probably chatted with one on your phone through SMS, or maybe when you've been trying to make a change to an airline ticket or something, you've talked to one through your airline's app or through their website. And this Azure AI bot service actually makes that a lot easier to build. And it does that by giving you a few different ways that you can build this. Number one is this web-based, like interactive drag and drop chatbot designer thing that's called the Bot Framework Composer. So you can do that if you have sort of a simple rules-based system. You want to draw the different flow diagram arrows between the different ways that things can go through your chat system. You can do that. On the right side, you see the Power Platform there. So if you're building applications internally using Power Platform, you can build a virtual agent on Power Platform. And then the most powerful and flexible of the options in the middle is what's called the Bot Framework SDK. This is obviously available for multiple languages, including as a NuGet package for .NET developers. The way this basically works is that you build a REST API, and that REST API could be in any technology that's capable of building a REST API. But for our purposes, let's talk about that as an ASP.NET Core application. And the user is going to come in through some channel. When you set up the AI, the Azure Chatbot AI resource, you'll actually register it with different channels. Those channels could be all kinds of things that you can imagine. It's like SMS, phone numbers, it's Slack and Teams. Also, there's a web-based version of it. So any channel you can imagine wanting to chat over is probably available in that list of channels. And then that channel is going to then basically send that data that people are chatting over the wire into your bot service, which is going to route it to whatever endpoint you've configured for your REST service. And that REST service could be, in our case, it could be an Azure function running .NET code. It could be an ASP.NET application running somewhere. But as long as it responds in the format that the SDK is expecting, you can use that to basically be the endpoint that responds back to the user and receives their responses. It's really easy to set this up. Once you install the NuGet package, you just create a controller, and you follow this format where you have a post that receives a message from the body. And that message is coming from the namespace, the chatbot SDK namespace. And then you can imagine here, of course, we got a really simple example here. It's just saying if the type of message coming in is a message type message, that means it's from the user directly, then go ahead and just respond back immediately and said you sent however many character length characters back to them. So this is a very simple, but you can imagine a big case statement here, or a big if, else if statement here that says if the message has this word in it, do this. So you've seen some of these simple menus before where it says, here's the list of things you can say, and you say, reservations is one of those options, and you say that back. You can imagine that code here that says, if they say some form of reservations, then respond with this particular response. You can also imagine maybe integrating some other AI in here to recognize what the user is saying. Maybe you don't want to do such a rigid menu system, but you want to do something that's maybe a little bit more flexible. And you want to get the kind of general intent of what the user is saying, and then based on that intent, give them different responses from different categories. That is also possible with some of the services that we're going to look at in just a minute that are based on Azure AI. So you could integrate some other Azure AI into here as well and make it a little smarter. All right, the next one I wanted to talk about is the Azure AI Face APIs. This allows you to basically do three things. You can detect faces, you can recognize those faces, and you can then analyze details of those faces. This is a list of some of the different things that it's capable of doing. So it can detect faces in a photo or a video, how many people are here, basically. It can recognize ones that it's seen before, so you could give profile pictures of your employees and create like a camera-based security system that says, if you see any of these faces, recognize this face in the employee database, then go ahead and unlock this door, something like that. It does emotion analysis, so if somebody's mad, upset, angry, bored, falling asleep in my talk, anything like that, it might recognize those different emotional states. It can also do things like guess or estimate at the gender or age of the particular face that it's looking at. It can do some of the face landmark measurements that you might want to do if you're doing more deep analysis, like accurate security information with faces. It can tell you things like how similar two faces are. So quite a bit of stuff that it can do with faces. Just like the other API we looked at so far, the other ones we've looked at so far, it's really easy to use. You're going to set up an Azure AI Face resource in your Azure portal, and then that's going to give you an endpoint and a subscription, an API key, and you're going to use those two together along with the Face client class to connect into the endpoint, and then you're able to do all kinds of different functionality that we just talked about. In this example here, we're actually passing an image URL from the internet, not a real one, but an example one. And we're passing that to the API and asking it to detect any faces that are in there. And then you can see it comes back with a detected faces response, like an I list of detected faces. And we're looping over that, and we're saying what the unique ID that it generated for each of those faces was, as well as a guess at the age and gender of each of those faces. And you can also look at that more detailed information, like how accurate it thinks its guess is and things like that. So pretty powerful tool there if you're trying to do any kind of face-based security or anything with faces like that. Azure AI language. This is a really useful one. Just note that a lot of those services that I told you that went away, several of those actually landed inside of this one. Probably the most important one of those is what's used to be called Lewis, which was the language understanding AI. And that's probably the majority of the functionality that's now in the Azure AI language APIs. So what can this do? Well, it can do a bunch of different things. It can do named entity recognition. What does that mean? Well, it means you give it a whole bunch of things, and it can say, you can give it a sentence and say, that is a poem, or that word is a noun, or that word is an adjective. So it can basically classify things. It can also look for personally identifiable information. So maybe you've got documents that flow through your application. You want to make sure when someone uploads a document, it doesn't have their social security number or something else in there like that. That might be a little bit too much information to store, credit card numbers, et cetera. You can actually scan that document using this service and say, flag with a level of certainty anything that might be personally identifiable information in here. You can send it documents or text and say, what language is this in? I actually, a few years ago, wrote something that used this particular functionality. I was trying to take an RSS feed that had a bunch of blogs about a particular topic, and I was trying to only take certain ones that were written in English and have them automatically publish to another feed. And to be able to do that, I was able to basically have that RSS feed read by my .NET code, to then go to the website for the particular URLs that were in that RSS feed. I was able to take the text of those endpoints, and I was able to pass it to what used to be called Lewis, and it's now the AI language APIs, and say, what language was this blog written in? It would come back with the language, it would come back with a certainty, and if it said, if it was like over 95% sure that it was English, then I would go ahead and pass that RSS item through to the destination that I was trying to send it to. So it can be very useful to be able to detect that. Sentiment analysis and opinion mining, those are all things that you can do. And then summarization is another thing that's really useful. You've maybe used ChatGPT for this before, where you pass it a big document and say, what's this about? This can do that as well. Just like the examples we looked at before, really easy to use. You're going to set up your resource in Azure first, and that's going to give you an endpoint and an API key. You're going to then use those with the text, in this example, the text analysis client. Each of the different functionalities in this case still have their own separate class. So we're doing text analysis in this case. And we'll go ahead and connect to that. And then you can see here that we're getting the sentiment of these reviews that we're passing to it. And we're looping over those results and basically counting how many of them are positive, negative, or neutral, and then writing that out at the end to say, how many of these reviews were good or bad or indifferent. The next one I want to talk about is Azure AI Speech. So this actually does speech recognition, but also does speech synthesis. Synthesis is just a fancy way of saying that it takes text and it generates realistic sounding speech. I don't know if we have any like Instagram Reel fans or TikTok fans in the room, but you've probably seen on those platforms now there's a lot of videos that are clearly not real people that are doing the voiceover, but are just realistic sounding AIs that are doing the voiceover. And this is the type of thing that you could use to do that. You could also write a script if you're trying to make a video voiceover. Maybe you don't feel like you have a Hollywood voice and you want to make a professional sounding voiceover for it. You could pick from a whole slew of different like virtual actors that have different voices, and you could have them read that script that you wrote as a voiceover for a video or something. So a lot of really different ways that you could use this. Again, just like the other ones that we've looked at, it's really easy to use. You'll set up the resource. Once you set that up, you're going to get your API key and endpoint. You're going to use those to connect using the API. In this case, if we want to actually play the audio through a device, on the device that this code is running on, we actually have to have an audio device set up. So in this example, you're seeing an audio device being set up. And basically, the voice is going to say, hello world, and speak it over the default audio device. Now, I have a sample of this, but I don't know if my audio is going to play through on my from my computer to the speakers in the theater here. So we're going to try, and we're going to see if this works. And if it doesn't, just clap because it was so great. Okay? All right, so here we go. Let's see if, yeah, it does not seem to be playing through in the room. So I'll describe it for you, and then you can clap. Does that sound good? All right. This is one of the problems we were having at the beginning here when we started late, is that we couldn't get the audio working. So what you can see on the screen here is actually the web interface for the Azure portal. And this is me just sort of setting up some different test text to be synthesized into speech. And I've set these all up to be spoken by the character that's referred to as Jenny if you actually click through on the right over there, you'll see that there's a whole slew. I can't remember how many US English characters there are, but there's a lot. There's the most of any particular language. You could also pick a British person if you want your text to sound smart, or you could pick an Australian person, or Spanish, or really, you name it. It exists on there, and in some cases, there's many, many characters that you can choose from. So I picked a character that's called Jenny, and then for each of these texts on here, I went ahead and told it to use different inflections on them. So the first one was just sort of a flat inflection. The second one was to say it very cheerfully. Then I had her say it in a terrified voice, which is the one that is the most fun to hear. And then I had her whisper. So there's all these different inflections that you can use as well. Okay, now you can clap for the demo if you want. The next one I wanted to mention is the translator service. You've seen this one before probably. If you've used PowerPoint actually has an automatic translation. So you've seen this before if you've seen the closed captioning sort of appearing live as someone is speaking at a conference, or if you've used that feature in Teams where you're talking to somebody who speaks a different language and the closed captions are showing up for them in their own language for what you're saying in English. A lot of really cool uses for this. 100 different languages, over 100 languages that are supported by it right now. This example is also using an API key and endpoint for the resource that you would set up in Azure. But it's also using something else, which is called a SAS URI, which is just a shared access signature. If you've ever done much with Azure Blob Storage, you might be familiar with these. This is a way that you can write directly to or read directly from a particular blob without having like a special access token. That's like a global access token, but this is like a document level access token. So this is actually reading in a particular document from a blob URI, and it's going to then convert that, you can see, to French. And then the rest of this code just completes that operation and writes it back out into the target blob storage. So basically translating a document from one language to another in just a few lines of code here. Okay, so you get the idea that there's a lot of services that you can use in Azure AI. And we've seen a few of them. I want to mention a few other things that go a little deeper. Each of these examples goes what I would consider into like a deeper level of AI. So this one is Azure Machine Learning. You can think of this as basically machine learning in the cloud. So Azure Machine Learning provides you with a set of tools that allows you to both build, deploy, and then also to manage your machine learning models, and then to run them at scale in the cloud. It's got all kinds of great tools built into it. It's got this machine learning studio. You think of it as sort of like a design surface or like an IDE in the web browser for machine learning. It's got something called AutoML, which is great if you're like me and you're not a machine learning expert, but you have a set of data that you know you want to do machine learning on. You can show that data to it and use the AutoML feature. It'll suggest what type of machine learning model might be best for your data and for your purposes that you're trying to use it for. And it's got a bunch of other tools in there as well, including like a repository or library of models that other people have published that they can version in there, and some responsible AI tools to help you make sure that you're doing AI machine learning in the best way possible. This is what it looks like to use Azure Machine Learning. Just like anything else, you're going to connect to a particular endpoint. You're going to use an API key to do that. In this case, we're taking a piece of data which has temperature and humidity, and we're asking for a prediction. You can imagine this prediction being something like, is it going to rain based on this data? And this model would have been trained, obviously, on a bunch of other temperature and humidity data that might allow you to have some more accurate predictions. Of course, this might not be enough data to really do that, but maybe it's enough to get a rough sense. So that's a way that you could do machine learning if you're trying to take a set of data and make predictions based off of it in the cloud. But what if you need to do the same thing, but you are going to maybe do it in a mobile app that's not connected to the cloud all the time, and you want to be able to accurately, let's say, detect anomalies in some data that's coming from a Bluetooth device. For example, at Trailhead, we've written an application that does that for children who have chronic illnesses, and their parents have an app where they can monitor their vital signs. Of course, if a child has a chronic illness, getting a fever or something can be life-threatening, and so this device, this Bluetooth device, measures their vitals, and on the device is actually detecting anomalies. Even if the parent's device is not connected to the internet, we can detect anomalies right there using a machine learning model and upload that data into the cloud later when they have a better connection. So if you want to do machine learning, but you want to be able to do it sometimes offline, or just embedded inside of an application instead of having to make calls out to the cloud to do it, machinelearning.net is a library that you can use to do that. One of the things that's kind of cool is if you use Visual Studio, it's got this great model builder that you can add into Visual Studio as an extension. You can see in this example here, it's loading some data into it, and then it's training off of that data. And when it finishes training, then it'll do an evaluation off of a different set of that data. So it's basically taking, I think it's 2/3 of the data and training off of it, and 1/3 to see if the data is actually, if the model is actually working to be predictive. It tells you how far off the predictions are. You can try different types of models, and all right there in Visual Studio. And then the output of that is actually a zip file that has your model basically all compressed inside of it as a single file. And as you can see, if you want to use that model, now all you have to do is embed that zip file into your application in some way, and then you access that zip file using the SDK for ML.NET. You can load that model up, you can give it some new data and ask it to do predictions based off of that. So really powerful. It also has some of that auto ML functionality. It also has a CLI tool if you're a .NET CLI fan. You can do all of that stuff you saw in Visual Studio at the CLI. So if you use VS Code instead of Visual Studio, you still have all that functionality available to you. The next most complicated thing I want to talk about is semantic kernel. Semantic kernel is another tool Microsoft publishes. This is basically what Microsoft has used to build all of their own copilots. So I've lost track of how many copilots Microsoft has right now. I think there's a new one every day. But however many they have, all of them are written using the semantic kernel as a way to orchestrate all of that. It's a very complex thing to learn, so I'll just kind of warn you, like as we're going through these examples, we're getting deeper and deeper, and this is a more complex thing to build. But if you wanted to build your own copilot that worked its own way and did its own things that the copilots that Microsoft has built don't do, you could certainly do that, and all of the tools that you need are available here. The semantic kernel itself is the orchestrator. It's kind of the traffic cop of all of this, but it uses things called connectors and plugins to do this work. So there's also something called a planner. That's kind of the brains of the operation. The planner will use usually a large language model, and you can configure it to use any large language model you want. Obviously, OpenAI and ChatGPT are sort of a default, but there's many others you can choose from. And it'll actually take some sort of a prompt from a user, use a large language model, and the data that it knows about all of the different plugins and connectors that it has, and it will try to turn that user's prompt into actions that it can take using these different plugins and connectors. So the connectors are basically a way that you can connect to some other external system. You could think of this as like APIs or a database connection or maybe a connection to the file system. All of those things are possible. And then plugins is basically like a library of functionality that is extensible. So you can add your own plugins to your code, to your semantic kernel code, and add functionality that particular copilot is capable of doing. I'm going to kind of skip over this example here so that we can get into a couple of other things. The last tool I want to mention is something called the cognitive toolkit. And as I said before, each of these tools that I'm talking about now is getting deeper and deeper. So the cognitive toolkit is if you say all that stuff is great, but I want to actually build my own deep learning model. I want to build my own neural networks, basically. You can build your own neural networks in .NET using the cognitive toolkit, which, by the way, for short, is often referred to as CNTK. So the cognitive toolkit lets you build all kinds of different neural networks. The most popular ones listed up there, the feed-forward, the convolutional neural networks, and the recurrent neural networks being examples of the kinds that you can build. This is what a feed-forward one looks like, if you're not familiar with it. This is what a recurrent one looks like. Just basically adds the ability for the nodes to go back to themselves. And a convolutional neural network is quite a bit more complicated than either of those. These are really good at things where there's like two-dimensional data or grids of data that you're trying to process. Images, videos are good examples of this, what this is good at. And you can basically build your own. I'm not going to spend a lot of time on this code example, but this is a very simplistic code example that creates a convolutional neural network that has 2 layers to it for image classification purposes. So if you wanted to build your own neural network, this cognitive toolkit is something that you could look into a little bit more. I also wanted to mention a few other things that we don't have time to go into today, but that are available out there if you're a .NET developer. If you've heard of TensorFlow, this is a machine learning platform. If you want to use that in .NET, there's TensorFlow.net, which provides .NET standard compatible wrappers for all the TensorFlow SDKs. Accord.net is a machine learning framework that is specifically for audio and image processing. And this library was actually all written in .NET, so you can use that in your .NET code very easily. And then the last thing I want to mention is that tools like the Cognitive Toolkit actually implement a standard called ONNX, or ONNX, which is the Open Neural Network Exchange. So if you've heard of some of the other neural network technologies that are out there, most of the major ones implement this, and it's a way for them to basically talk to each other and interact in a consistent way. So that's something else that you could look into if you're looking to use a different type of neural network in your .NET code. It's very likely that you'll be able to do it using ONNX. So a few things to just keep in mind. There are challenges and considerations to make if you're using machine learning. And just to kind of sum up some of the things we talked about today, AI might be a buzzword right now, but I think it's also very important. And it's something that you're going to want to consider, how am I going to integrate this into my applications? It's really only good at certain types of problems. You really can't AI everything, but you can AI things that AI is good at. If you're looking to do a very simplistic way to get started with AI, Azure AI services are a great way to outsource that into the cloud and get started with the advantages of AI right away without having to know how it all works behind the scenes. If you're more interested in machine learning and you want to do that in the cloud, you can use the Azure Machine Learning service. If you want to do it more on hosted in your .NET code, ML.NET is a good option. Semantic kernel, if you're wanting to build your own copilots that are extensible. And the cognitive toolkit, if you want to build your own neural networks. So the last thing to remember then is that AI isn't good for everything. It has drawbacks, like it's only as good as the data that you give it, for example. So just keep that in mind, that if you do not have good data and someone is saying, oh, we should maybe build a machine learning model off of this data and make predictions, well, you're probably going to get bad predictions if you have bad or inaccurate data. So that is about the end of my time there. I just have a second for questions. So is there any questions in the room or on Discord that I can answer right now?
I have a question here in the back.
Yeah, go ahead.
You were talking about using Azure OpenAI within C#.
Yeah.
Just wondering if there's maybe a GUI interface you can dialogue with it with, like GPT.
Oh, yeah. OK, so the question is basically, is there an interface that you can use, like a web interface, to interact with Azure AI endpoints? I don't recall there being one. One way that you can do it is it's the same models that are available in OpenAI. So you could just log into OpenAI send messages to that, and you're going to get a very similar response to what you might get from your code. Yeah, great questions. I'll be up front if you want to have any others, and thanks so much for coming today. Appreciate it.